Well, we're doing a little continuing on the lockdown boat designing. This one is we call it a tunnel boat. It's because it's got an air channel down underneath the bottom of the boat that takes a lot of the weight off of the boat and cuts hydrodynamic drag. These are generally built, open class hydroplanes are built on this similar plan, except that the side pods go farther back and it rides on the tail end of the side pods. It makes it easy to turn, and it cuts drag because that's the only thing that touches the water is the little bit of area near the back of the pods. But it's not very stable. Worst problem they have is there gets too much air under it and it starts to rise, and then it sees more surface area and it blows the boat over on its back. That's why there's no top in the cockpits on these style of boats, so the occupants get tossed off the boat. Let's see here. It's kind of pointy looking. And this shows the tunnel down the middle of the boat. The air's got to go under that much of it. So we can get around to the back here. Now, this is called a three-point hydroplane because there's a flat panel under the bottom of the transom back here that slants up going towards the front. And this rides on the water because the center of gravity lies between the sponson and this trailing edge. These kind of boats tend to sink at the dock. They hold them up with cranes if there's any kind of a wake or waves or something, because they'll wash right over and put them on the bottom. That's the reason for this side enclosures around the engine. But sitting with nobody up here counterbalancing the weight, they would tend to not have much, especially a two-point one. But a three-point one can still have that problem, just not as much. So to solve that, this boat was made wider above where anything will be riding. So, but if it's sitting at the dock, this part here, when it starts to tilt down, this goes underwater and provides buoyancy. And it can tilt, 7 or 8 degrees. But the water will never get up here because you see how much airspace. It's, 3 times the weight of the boat. So it's not going to do any sinking. And this is not for going racing. This is just to have something that's kind of fast to play with. The cockpit, it's flat bottomed, and in final drawings will be a series of 2-inch holes here under the seat. If you do get water in the boat, if it's moving forward at all, the bottom will suck that water out. Or if it's higher than the holes and just air's under it, it'll run out by gravity. But that's the plan on that. The front here is nearly level, rides above the water because the boat is sitting on this right here and that little bit of tailplane. So this just cuts the air and forces more of it to go down underneath. The sponsons here, they edge up. So as more and more the boat comes out of the water, as the speed goes up, less and less is touching the water. It'll eventually get to where it's riding on about maybe 4 inches of this by about 2 feet long. Let's go to a different view here for a minute. No, I think down here below. This ought to be a better explanation. Okay, this red line, which is not on screen, let me get it on your screen. It's on my screen. Yeah. I don't know if it'll show up here if I click it. No. It's a bunch of stuff grouped together here. Okay. This is actually not a line. This is the bottom surface of the boat. This is built like a stitch and glue boat or anything that's built out of flat materials like plywood, steel, aluminum, anything that doesn't take compound curves. It's not stretchy at all. This boat here is designed to be built out of 1/8" stainless. Could be built out of 3/16 A36 plate just as easy. It would weigh more, but easier to fabricate. You don't need a plasma cutter to cut it. Anyway, the air comes in here, he gets forced down, and in the actual drawings there will be a metal strip that starts about at the end of this curve. It goes down to about 1.5 inches below these, and then it runs level, the running level, whatever it is when it floats, back to the back. And that traps the air in the center to make it provide lift, basically. As long as it doesn't cause anything to suck down, you're breaking cavitation of the water underneath here. Let's go back to where we were. Well, I don't know. Wait a minute. Yeah, we go back to here. There's other things. Every one of these views has got all the stuff in it. Oh, that's showing that shape of that bottom piece of sheet metal. Well, that doesn't show it worth a crap. Thought it might, but it didn't. See, as long as you have a bend that's just crosswise or diagonal or anything that's it's only bent in one direction, then you can just form that. This is intended to be a welded hull, so the stitches are welds. You'd put a tack up here, and you pull those two sheets until they touch. You can clamp some angle iron on it, or you can get a chain hoist, what's called come along. But you get the first two bits of it together somehow, and you get a pretty good tack, and then you go back in front of that tack and weld about 1 inch. Okay, and after that, you take a flat side of a 2-pound ball peen hammer and hit this surface flat and that surface flat. That'll suck that corner together, that edge together. And then you move towards about 1/8 inch apart. You put your 1/2 inch tack, and while it's still red, you smack it with a hammer in the two directions, and that'll suck that together. And you basically just walk down all the seams, putting tacks. This is just like a stitch and glue boat. And then you can come back and you can weld the back side, and then you come back and weld front side. But the trick to these things is making all these shapes that are curved edges when they're laying flat. When it's a piece of metal laying on a workbench and you want to cut this shape, then that's the whole trick to this computer-aided design, is it does that very well. If you look at this, you'll see it's a straight line. That's a straight line. It's bent around, but it's a straight line. Everything here is a straight line. That's a straight line. This is a straight line. The line across the front here was a straight line. To draw this stuff in CAD, you have to have the angle that you want this line to be. So you would draw a line, but you would draw it out to here and maybe out to there. Just the angle is all you need. And then you go to another view in your CAD, which you'd be looking at down from the top. And you construct a line either with polyline, or you draw circles and tangents to circles. You can use 3 or 4 different radiuses, join them together where they're tangent. And any way you want to come up with this curve, you can freehand it on the computer, but you're better off to have it more of a mathematical kind of curve. I use polylines. What do they call it? Let me see here. Control point curve. That's better than the other option, the right click, which is through the points. You have points and then it makes a line which guarantees it goes through those points. But for this, I kind of like the control point curve. If I turn points on, and I'm not sure where to do that, it's a command you enter up here. I don't ever use it, so I think maybe it's just points on. Anyway, what it'll do is you'll show you the points. There'll be a point here at the end, maybe two of them close together. Then there'll be one up here someplace, and then one here. And what that does is the point up here tries to drag that curve up, and the one back here starts dragging it back down. Then you want it to go through a particular place. You put two or three points together. Like 2 points here, the point that you want, then a couple points going down. And then you have a point down here someplace and a point back here and one at that end and a couple behind it. Because you're going to trim them all off. Anyway, you've got this diagonal line. And this is the same as if you're doing a sports car body with those angular curves like the GTP cars have. If you're trying to make that kind of a shape for a hot rod for the street, you do it the same way. You have to use straight lines because you can only bend sheet metal and things in one direction. Plywood, same thing. But you take that curve and you just attach any part of that curve to this this line that you got here. Just bump it up to it or near point of it to an end point and stick it on that line. And then you go up to surface, sweep one rail. Up here just off the screen, it says select rail. So you would pick a rail, and then when you push enter, because I didn't pick a rail, it's not going to do anything. It would it asks you to the line you wanted to sweep. You also have a surface sweep 2 rails. If you're going to do that, if you have the 2 rails, like if I'd have drawn this line here looking down on it, and then I know that the sponson is going to end right here, so that's a point, and I can decide how much of an angle I want on this, and I can make another line in here. Or I could take this line and offset it in like 3 inches so I have a beveled side so that it doesn't dig in on turns and flip over sideways. You turn these things, they turn really sharp, scary sharp. But then I would work that line around till it touched here and trim off some in the back, maybe cut a piece out of the middle. Better off just draw another line. And if you have the 2 lines, then you just draw a single line between like you go to the back where there's a separation, and you draw that piece of line just point to point, and then you use those 2 for rails, and you sweep this line, and it makes that shape. So now you got these big rectangular pieces of sheet metal, and you trim off everything that's not part of the boat. You would trim this line, and you would trim the line down the center, and you'd get that panel. And because you've done it that way, it's already to the shape. Of course, you're going to make it flat to cut it out. But now you see, this is done in. I was more concerned in getting this area right here and this area here just the way I want it. So I only drew the front half of the boat to get that right, and to find out where this was going to end up. I got to get it under a place big enough to sit, and then I got to have enough space for the engine and like a Volvo Penta outdrive or a MERCRUISER outdrive in the back. If I did MERCRUISER, this would have to be farther apart because that'd be a V8. The Volvo Penta is a straight 4 or a straight 6, depending what you buy. But you have some rough dimensions you have to make it bigger than so that people can fit in here and the engine can fit in there. And then I did this as a separate piece. The bottom was done as one piece. It was an add-on. But this, because I can't unwrap a twisted surface, I really can. I've done it before. I do airplanes, so you have a lot of surfaces that are changing airfoils from one place to another, and a common way to make the ends of the wing stall last, so you have control just before it quits flying and tumbling. You would have less angle of attack at the tips, so that as the nose rises and the wing starts to stall inboard to outboard, the last thing flying is out there at the ends, and all your controls surfaces are on the end, so you can still control it. But that's a twisted surface, and if you cut this this panel into pieces like 3 inches long, and you unwrap the 4 points, and then you stick them all back together. There's a video here on Surfboard Sailboat. It should be posted before this one, and the inside of this cockpit on that thing didn't want to loft, and then it didn't want to unwrap. So I cut it into like 4 or 5 pieces and unwrapped it and then stuck them back together, and that's detailed in the video. So yes, the same thing you would do if it was a twisted surface. You can do it. But you're better off, you get nice geometric NURBS curves if you do it the way I'm doing this one. All the parts fit together perfect. You can have 0.3% error if you cut this in strips. It'll still go together, but it won't be exactly what you drew or what you thought you're going to get. And if it's got a 0.3% error, when you're sticking this edge together, you might have to work it from one, and it'll never actually just fall into place. Like when you get about to here and you expect it just to all flop over and be right where it's supposed, it'll still have a gap. Or it'll be up underneath the other and you got to pull it out. It's just harder to put together. And I don't think it makes it any faster or look any better. You either like the look or you hate it. It's just the way it is. If you don't like the look of this one, you really might not like the next one. I'm doing a 16 by 32 foot houseboat that we can go island to island here. Like we want to go to Cebu someday, we can get on it. And the first floor, the deck between the sponsons is it's 26 feet long. We can park our Kia Envoy on that, drive into it from the end. And the one end of the first floor is a roll-up garage door. And if you start getting into waves that are 3 feet high, you shouldn't be out there in the first place. Because you get there and the wind picks up and the waves pick up, you roll up the garage door, and the front is pretty much open. And they're wave-piercing pontoons basically on the side. The point is lower than the center line, so the water can wash right down over that lower deck and out the back. You don't want to put 10 tons of water in something you're trying to float, especially if the water's rough. And then there's 4 staterooms on the next floor and a party deck on the top. The first thing down here where you park the car is the galley, eating tables, stuff like that you can throw everything in a bin. As soon as the weather starts looking bad, open the bins and just dump everything in it. If you're in the middle of cooking, just put it in the drawer. It's better than the other